Hi again. In our last session, we took time to look at inductive arguments, which are arguments that are probably true. And now we're going to look at deductive arguments, much stronger form of argumentation. And an inductive argument is either true or false. There is no scale with a deductive argument, excuse me. So there's this great saying, when you have eliminated the impossible, whatever remains, however improbable, is probably or must be true. A deductive argument claims that its conclusion necessarily follows from its premises. So when we have those premises laid out, the conclusion must follow from those premises. Certain words and phrases, as we spoke about in inductive arguments, so too in deductive arguments, we have indicator words. And these indicator words are words that are certainly, absolutely, definitely, conclusively, must be, and it necessarily follows that. Those are indicator words. When you see a word like necessarily follows, or conclusively, or it is definitely true that, you know you're dealing with a deductive argument as opposed to an inductive argument where it is probably true, and it's on a scale of weaker to stronger. It's either true or not true in a deductive argument, and so we use words that imbibe certainty. A deductive argument claims that its conclusion, as I've said, necessarily follows from its premises. Certain words and phrases we've spoken about, but not all deductive arguments contain indicator words. Deductive arguments often use syllogisms or are comprised of syllogisms. A deductive argument is presented in the form of a syllogism with two supporting premises and a conclusion. And I drew a definition of a syllogism for you from Merriam-Webster's dictionary, and it is this. A syllogism is a deductive scheme of formal argument consisting of a major and a minor premise and a conclusion. That's a syllogism. So you have your major premise, your minor premise, and then your conclusion. And we'll see this when we're diagramming arguments as well, how that flows through your major, your minor, and then your conclusion. And here's an example. Every virtue is laudable. Kindness is a virtue. Therefore, kindness is laudable. Your major proposition or your major premise, every virtue is laudable. Your minor premise, kindness is a virtue. Your conclusion, kindness is laudable. So, when we're thinking about deductive arguments, just as with inductive arguments, there are also types of deductive arguments. There are several types of deductive arguments. Just as in inductive there are three, so in deductive there are three that are used in everyday reasoning. Arguments by elimination, arguments based on mathematics, and arguments from definition. An argument by elimination rules out different possibilities, as we read in our opening statement. When you've eliminated all possibilities, what remains must be true, until only one possibility remains. Arguments based on mathematics depend on mathematical or geometric equations to generate conclusions. And in an argument from definition, the conclusion is true because it is based on a key term or essential attribute in that definition. Hypothetical syllogisms. Hypothetical reasoning involves if-then. If A is B, is C, then A is C. We'll look at this. A hypothetical syllogism is a form of deductive argument that contains two premises, at least one of which is a hypothetical or conditional if-then statement. There are three basic patterns of hypothetical syllogisms: modus ponens, modus tollens, and chain arguments. And those are fancy names, but they help us to identify different forms of hypothetical syllogisms within deductive arguments. A modus ponens argument uses the following structure: if A, then B. A, therefore B. A modus tollens argument uses this structure: if A, then B. Not B, therefore not A. In a chain argument, we have the following structure: if A, then B. If B, then C. Therefore, if A, then C. And you have some great examples in your textbook of these different types of modus ponens, modus tollens, and chain arguments. So, in using hypothetical syllogisms and using those various forms, we realize that not all valid arguments are sound. Rewording arguments in ordinary language in the form of hypothetical syllogisms can help you expose faulty premises. Remember, in a deductive argument, the conclusion must follow from the premises. And if you have faulty premises, then your conclusion your argument is not true. They're also useful as clarification tools and as decision-making aids. A deductive argument is valid if the form of the argument is such that the conclusion must be true if the premises are true. The form of an argument is determined by its layout or pattern of reasoning. An argument is sound if both, one, it is valid, and two, the premises are true. Then we have categorical syllogisms. Just as we have hypothetical syllogisms, we have categorical syllogisms. A categorical syllogism is a type of deductive argument that sorts things into specific classes or groups. It is composed of a conclusion, two premises, and three terms, each of which occurs exactly twice in two of the three propositions. That sounds very complicated. Again, your textbook unpacks it really nicely. I'll just give you some standard forms of categorical syllogisms, and hopefully with the Venn diagrams, this will become clear to you. So a standard form for categorical syllogisms as opposed to hypothetical syllogisms are as follows. All P are or are not M. P is the predicate, M is the middle term. Some S are or are not M. S is the minor term and M is the middle term. And some S are or are not P. So S is the minor term and P is the major term. As with hypothetical syllogisms, in the form of a categorical syllogism is valid, then the argument will be valid regardless of term substitutions. And I'll show you how this works in a moment. Each proposition in a standard form categorical syllogism is written in one of four forms based on quality, universal or particular, and qualifier, affirmative or negative. So it's either positive or negative, and it's either universal or particular. Universal, all S are P. Universal negative, no S are P. No dogs are reptiles. All S are P, all dogs are mammals. So we can have a universal affirmative, all dogs are mammals, or a universal negative, no dogs are reptiles. Or we could say, no snakes are mammals. And we can have a particular affirmative, some dogs are reptiles. Well, of course, that's not true, so we'd have to change that. But we can have a particular affirmative where we can say that some dogs enjoy meat whilst some dogs don't enjoy meat. All right? Moving on to our Venn diagrams, which help us understand much more clearly these categorical syllogisms. Venn diagrams are useful for diagramming and evaluating categorical syllogisms, as I've said. So here's the visualization. No dogs are cats. Some mammals are cats. Therefore, some mammals are what? Not dogs, right? If no dogs are cats, and some mammals are cats, therefore some mammals are not dogs. And we can see that very clearly in the Venn diagram as it's relayed here. Translating arguments into standard categorical form. Number one, we need to rewrite each proposition in standard form, starting with the conclusion. We need to use the context and grammar of the original argument to decide on which qualifier to use. And we need to identify the three terms in the argument when we're dealing with a categorical syllogism. Where necessary, we need to rewrite each term as a noun or noun phrase. And each proposition uses a form of the to be verb. We need to assemble these in standard form with a major premise, a minor premise, and a conclusion. Knowledge of deductive arguments, including arguments from definition, mathematical arguments, arguments by elimination, and hypothetical and categorical syllogisms, is essential for us to effectively function in the world. As good critical thinkers, we must constantly identify and evaluate these types of arguments, both our own and those presented to us by others. Thank you.